always on deck, breaking all the specs, relativity theories. Worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold. Brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down. Actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice.
What's up, everybody? All right. Oh, I gotta start the stage on Discord. I hate, dude. Daylight savings messes up all the Discord stuff for the times. I get so annoyed at that. Discord like doesn't know what to do with daylight savings time. Okay, we're gonna stream there. That's working. What's up, Frozen? What's up, guys? Happy Monday. Happy Thanksgiving Day, right? It's Thanksgiving? Not Thanksgiving, sorry. Happy St. Patrick's. What the fuck am I saying Thanksgiving?
Surprise, motherfucker.
God damn. All right, one sec. Let me, sorry. Auto find. Yes. Yes. Activate. Okay, one sec. We're getting all the chats in. Getting all the chats in. Oh, I need to log into this one?
So when did chats? So little time.
I'm trying to see if we can stream onto, what is it? Instagram as well. I'm just trying to like see if I can pollute the airwaves with knowledge.
It's not a contradiction.
Yeah, pollution with knowledge, I guess.
Yeah.
Pollutants, yeah. Knowledge is not a pollutant. Yeah.
Captain Planet.
Captain Planet. He's our hero. Gonna take pollution down to zero.
That should make a comeback.
It should, dude. Honestly, right? Oh, you got a cup of Java? Yeah. Oh, let me get you. I got my cup of Java today too. Let's see what I got. I got here we go. A little coffee.
In a gold cup.
In a gold cup. Has to be in a gold cup. What's up, Shantrix? How do you make your coffee sensation? Do you use Nescafe or something?
Yeah, pretty much. I mean, I do have a coffee machine, but I just can't be asked with it.
Can't be asked. CBA. Can't be asked. Let me see what this is doing. Oh, this is actually working now? Oh. Well, this one. So I gotta get rid of this one. Sec. Multi-chat. Let me get rid of that.
Just before we begin, how is your astrophysics?
How is my astrophysics? Decent. I actually really didn't like astronomy. I had a really bad astronomy teacher my first year of undergrad, and it kind of like turned me off to all astronomy, like in general. It's amazing how like one professor can really affect so much.
Yeah.
But yeah, what's up? Do you have an astrophysics question you want to go over?
Just in layman's terms. So
yes,
when you're in the system of a G-type star, it just is a constant flow of light, right?
Sure.
But if you look,
understand these words.
If you look at another system, you can see the rotating of the star, which is kind of a weird concept to me.
Okay.
I was just wondering why you can see the rotation from a distance, but not when you're up close.
Oh, I see. Well, how do we know we can't see it when you're up close? Are you talking about, have people actually been up close to stars to know that?
Well, you know what I mean. It's it just is solid light. But then stars twinkle, but then when you zoom in, it's like right there.
I see.
You can see it rotating.
Uh-huh. Okay. You're talking like here on Earth, if we start optically zooming into things, we can see things. Are you talking about with I mean that probably means with like what type of optics are you using for this? Just like a regular telescope?
No idea. I've seen it. It always looks a bit distorted, so I assume it's just normal.
I think stars twinkle, I believe, because of something with our atmosphere. Is that right? Is that why stars twinkle? You can see the planets rotate? Is that what it is? I don't know. Yeah, I'm not as. One second. Let's see. Why do stars twinkle? Just curious. Yeah, it's atmospheric scintillation. I knew it was something with the atmosphere. Yeah. Okay. Because their light, which is a point source, is bent and distorted as it passes through Earth's turbulent. Yeah. So the atmosphere is kind of like creating noise, I guess, which then causes these point sources of light to fluctuate. So what's the thing? Like planets don't twinkle, but stars do. Is that what we say? Oh, here we go. Stars appear as point sources of light, okay, while planets appear as disks. And the atmosphere, the chaos of the atmosphere has a much greater effect on point-like surfaces. Okay. Yeah. Planets can be resolved as disks. Okay. That's cool. Why is that? Why is it because the planets are closer? Stars are probably so far away that they look like a point source, whereas planets are decently close, not as far away as like random ass stars are. So we still see the whole cross section of them.
Also, not emitting their own light.
Yeah, well, I mean, they do emit light. Like some of them do emit light, you know. But a lot of them, you're right, is just reflecting the light of the sun, I guess. The angular diameter of a star versus a planet. Yeah, you could do this. Yeah, angular resolution. Yeah, totally could. Yeah, these are all cool things that could happen. 40 stream streak. Nice. Good job, Chantrix. I want to know why Instagram's not going live. I sent it the RTMP, man. You just got to go. Whatever. Free tutoring in math and science. No, we're not practice. We're public. One sec. Let me see if it actually got it.
You should just have like a weird title, you know, like they have in YouTube videos.
Oh, like something just get rage bait or something, basically.
Yeah, look how well this. Look what he's teaching. You won't believe this kind of stuff. You know what I mean?
Banks hate this one quick trick.
Yeah.
Oh, I see. They keep changing the stream key all the time. That's annoying. Oh, okay. Well.
Security.
Yeah, I don't know why they do that. Usually you're given like a single stream key and then that's it. But okay. Well, now OBS is like crashing. Oh no. Uh-oh. I might broke OBS. Okay, one second. We're just gonna get out of this. Get out, please. Cancel. Thank you. Okay, better. Alright, whatever. I don't know if we're actually working onto Instagram, but that's for another time. I know we're at least working for sure on Twitch. I think we're working on YouTube.
Yep.
Yeah, we got one view on YouTube and we got one viewer on TikTok. Nice. Okay, so that is working. Sweet. Okay. Nice. Today is St. Patrick's Day, right? Do y'all celebrate that over there in Scotland-ish area? Sensation?
Well, the English celebrate it.
But the Scots don't?
Well, any reason to get pissed, I suppose, but...
Well, I mean, yeah, any reason to drink is great, but, you know. What is it? He drove all the snakes out of Ireland? Is that how this works?
Drove all the snakes into the sea, yeah.
Oh, okay. From the river to the sea, the snakes will be free? Is that how this works? Is that what they're all chanting about?
I think it was supposed to be the Anglo-Saxons that are supposed to be the snakes, but...
It is funny how, like, snakes are a pervasive theme in a lot of, I guess, lore, right? And, like, legends and stuff, yeah?
Because they're deadly creatures.
Yeah, but it's interesting, because are there no snakes in Ireland?
There are no snakes in Ireland, but there wouldn't be anyway.
So wait, so how did they come up with the thing where he took all the snakes away? So, but there were no snakes to begin with. Okay, whatever.
Interestingly enough, there are grass snakes in England.
Okay, but there are absolutely no snakes in Ireland, and so they say that someone must have driven all the snakes out.
Yeah, I guess so.
Okay.
Snakes the snakes were metaphoric demons.
Yeah, it's a metaphoric demons. Also, I heard it's a metaphor for like DNA, right? Like the double helix is also kind of like the snake. You guys ever seen this? Yeah. Or what is it, like the snake eating itself?
The Ouroboros.
So
this is like the Ouroboros, right? This is a very famous thing, isn't it?
Yeah, it's Viking.
It's a Viking thing. Okay. What's up, Seth? What are you saying, dog?
Did you do the question about the generate rotation?
I don't think I did that. I haven't done any questions yet. We've been talking about symbols for magic.
Week.
Oh no, probably not. I don't think I've done it yet. Okay, Jeff says there are no native snakes in Ireland, and this is primarily due to the island's climate and history, After the last ice age, the land bridge that connected Ireland to Britain was submerged before the snakes could migrate there, and thus they never established a population. Oh, that's very cool. Nice. That was the last land bridge, Doggerland. Okay. I mean, there's also the, oh man, where they have it? It's like the snake on medicine. You know, guys, you know what I'm talking about? Yeah, this one, right?
Asclepius.
This is like, is that what it's called? Caduceus?
Maybe not Asclepius. I thought it was Asclepius, but I guess I'm wrong.
Harold's Wind is a staff carried by, yeah, Hermes, right? Or Hermes, however you pronounce it. So yeah, snakes are a pretty pervasive thing in a lot of old history. I mean, Adam and Eve, right? That's the classic, you know, snakes. Hippocratic Oath. Yeah, lots going on. Hermes? Is it Hermes? No, it's Hermes, is it? How do you pronounce it? One second.
I was right. Asclepius.
Clepius.
He's a hero god of medicine in ancient Greek religion.
Oh. Mercury.
He made the snake lick the eyes or eyelids of a blind man, and he could see. That's how I know the snake and the staff.
Oh wow. Okay. That's fascinating. Oh, Asclepius. Yeah. Yeah, this is it. The rod of Asclepius. Okay. Yes, because there's like Greek mythology, and then it goes into like Roman mythology. It's kind of like all over the place. But yeah, snakes are cool. I forget we got on the topic. Well, St. Patrick's Day, right? Apparently St. Patrick banished the snakes from Ireland, so that's where we got from that. Okay, cool. All right. Any other news? I hope you guys enjoyed Pi Day. I got to give points out for that. Thank you everyone who came by with to Zach's stream. That was really fun. I enjoyed all his trivia stuff. I'll talk with him. He has a cool platform. Maybe we can do some more events like that in the future. Romans just stole it and put a texture pack on Greek myths. Yeah, the Romans did kind of do that, didn't they? Yeah. All this stuff is the same. Did he bring them in so he could just chase them out? Yeah. Is that the conspiracy theory? Could be. Let's see. Today's Monday. Yeah, no other crazy news. I'm working on getting us some guests for Friday. It'd be cool to do an anime podcast on Friday. I did a post about you guys on LinkedIn over the weekend, so hopefully people understand what we're trying to do here and can get some cool people to talk to on Friday. But we'll see. Otherwise, oh, you know what I got, Sensation? I got a foot pad. I got a foot pad for my for OBS for like switching between scenes, so I can do this now with my feet. It's super cool because I used to have to always like hit something on a stream deck, but now I have like a little foot pad to like do things. It was actually really cheap. Actually, it was because it's used for like transcript software foot pad here, because there's a couple options for this, right? This is the, what is it, the Elgato foot pedal. It's called a foot pedal. Yeah, this is the stream. This is $90, which I was like, excuse me, $90 for a foot pedal? This is kind of a lot. But Elgato always makes stuff that's like super easy to like integrate with their other software. Yeah, so you can tap things and it'll do stuff. But I found this thing you can get on eBay for like $20. Yeah, it's this, but they have cheaper ones. And apparently it was used for like transcription. So people who were like transcribing subtitles and stuff would use them all the time, and so now someone wrote some open source software that you can just reuse them for OBS. Yeah, I want to get one for editing. Yeah, we'll just don't spend the $90. Don't do that. No. You can literally just go get one for $20 off eBay. It's called this. It's called the Infinity 3. I think I got like the Infinity 2. Here you go. This is what you want. Yeah, I don't think there's much difference between the 2 and the 3. But yeah, this foot pedal was $20. And it works. So we're seeing it work right now.
Because of how the Twetsons look. Because here's what we got in Twetsons. We got one from the 11th. We still got that Chantress one for the Cube. From a while back. We still have...
Swall's got a ton of questions. Swall just dumped like 40 on us. What's up, Swall? Where's Swall?
Still got two others from the 12th, and then we got the one from the 13th, and then we got the ones from today.
Okay.
So
I need the gold.
Let's not worry about it. Let's start with the ones 13th and past, because those are 13th and to today, because those are this week's.
Yeah, I like to generally go over the questions that are most recent, and then if we have time, I'll go back and do the previous ones from other days.
We can start. I know of the ones that we have here. 1, 2, 3, 4.
Also, I like to see if the students are here to do their questions. So in this case, Swa dumped like 10.
8 of the ones. 8 of these.
If Swa wants to show up, if you ever see Swa show up into the stage chat, just bring him in.
Is he not in right now?
I don't see him online, no.
Okay. So we can start with that dash then.
Yeah. What's up, Sensation?
You know, it's really sad that some people do things just for the money.
Yes. What's this? What is this? Mouth Monster Munch? Walkers, the crisps, the Walker crisps. Yes, I love those. Okay, so maybe we'll do a Darsh's question first, because I know a Darsh is here. And then Shantrix has some cool ones about Cat in a Hat. I like that. That's fun.
That one's an easy one, though. It's
okay.
Just a logic, easy one.
I don't mind things being easy. Okay, cool. All right, so that being said, let's start off the stream. All right. Welcome to Office Hours Actual Education. My name is Dr. Gold. This stream will help you with math homework, science homework, all sorts of fun stuff. Let's see what we're doing today. Adarsh says he is here. Okay, Adarsh, let's do it. Ooh, this is log-based, something with variables in it. Ooh, this is getting tricky.
This is actually a polynomial in disguise, if that helps.
Oh.
It
is, right? Yeah, okay, cool. Let's pull it up. Alright, let's see what we got. Famish said I redeemed first. Did you? Where did you? Oh, me first. Oh, you did Famished. Okay, Famished. Here, I gotta do Famish's question first. Adarsh, then we'll do yours. Famished did do the me first. We do have stuff that allows you to move to the front. Oh wow, dude! I know who that is. Oh, this time it's Sensation. Oh, I thought it was Sam. Sam's always making me hydrate. All right, Famish, let's do yours.
This one's nice and easy too, but it needs some work.
Simplify the expression, right, with positive exponents only.
This is his exponent rules. So
it is, but it's kind of like a huge mess of rules.
No, it's not huge. It's not a huge mess.
Well, here's a good question. Seth, what would you do first? Would you work on this first, or would you distribute this first?
I would do one thing first. Let's make that fraction 2 pieces.
Oh, this one right here. You want to make this one 2 pieces?
The fraction to become 2 pieces. That would be the start.
Okay, let's.
And then write the entire thing as one. Yeah.
So, I'm guessing you're gonna write it as like this part.
No.
No.
No. As 8x squared to the -2 on the top. And
oh.
3x to the 5th. Why does
I see. This is what he wants to do. He wants to do this. He wants to distribute the -2 to both the top and the bottom, which is cool. You can do that.
And also the 4xy minus 3 can go on the top, since we know that's on top.
After we've hit it with the -2, though, right? That's the question.
Well, it's part of the same expression. It's part of. It's counted as part of the top. So the parentheses now go away.
Yeah, so we can get rid of this. Goodbye. And now we just have this thing up here. Okay, cool. Okay. All right. Yeah, this works out well so far.
We can start canceling things. Hopefully.
Well, I think I want to distribute this in, right? Is that what I want to do?
Well.
Yeah, because I can't really cancel stuff yet. I almost would have actually canceled some stuff to start with over here, because x squared over x to the 5th. Yeah, I can write that as 1 over x to the 3rd, right? Yeah, that's okay. Let's do it this way. I mean, from what we remember, right? Even just from like basic PEMDAS. Yeah, parentheses first.
It's gonna be
and then do exponents.
It's nice that we didn't do that too, because it's about to cancel. It's in a distress anyway. It's in a cancel the top anyway. And it is too going to do the work and cancel. Yeah, Famish, you're not wrong. You could do this and just write this as to the 3rd and then write them in. That works as well. But we're going to do it this way. So we're going to hit the -2 is going to hit everything. So
another hill I'll die on.
What's the hill? What's the hill you want to die on, Sensation?
Not PEMDAS, BODMAS.
BODMAS? Dude, what's the... Oh, brackets. Brackets.
Orders, division...
Okay.
Exponents.
Y'all got the funny language stuff. Okay, this is 3 to the -2.
I don't agree yet.
What do you not agree with, Tom? What's up?
It's the squared to the -2 power, right? Okay, yep, I do. Okay, I saw my mistake.
Yeah, that's okay. Yeah, whenever you do power to a power, you got to multiply the powers together. So that's gonna be to the -4.
Okay.
Bedmas, Bodmas. These all sound like different versions of Christmas. Mary Bodmas. Fancy some Bodmas, governor.
Now,
that's a good one.
The next thing I'm going to offer.
Yeah.
Let's do our swap. What's a swap? What's a swap? Negatives to the top, negatives to the bottom.
Oh, I see. Yeah, so he's saying anytime we have
no negative powers.
No negative powers, we could swap
negative
things.
Powers.
We can, yeah. So we could move this one down to the bottom.
And make that power positive.
Make that to the Y to the positive third. That's correct.
And then swap. And then the 3 in the negative second will come back. Will join us. Will join the top.
Yeah. Everything's like moving around here. It's like musical chairs.
Yeah. Make sure it's. Watch yourself there, though. It's
that 4x3 squared. This looks ugly.
Yep. You parentheses that so it doesn't get part of the multiplication sign.
Okay, this stuff is positive, and then I think this stuff was negative, so now this stuff goes up to the top.
This stuff is going to go up and become positive.
Okay, cool. All right. Not so bad.
Really, what we really did is we swapped. We technically swapped.
We should have just flipped this. We should have just flipped this first off with the negative and just like made life really easy.
That's what I meant. Is that we just did that technically.
All right, we're doing this the messy way, and then we'll show the faster way to do it later.
Yeah. There's once I kind of saw the faster now.
Okay, so first of all, x, x, x. So this gives me x to the 11th over x to the 4th. That's gonna give me x to the 7th.
7th. Right? Yep. The 7th. Yep.
And then here, let's like cross these things out so we don't deal with them again. Okay, and then I have
3 squared and an 8.
Y to the 4th over y to the 3rd, so that's just y to the 1st, right?
Y. There's no y to the 1st. You don't need a first power.
Oh, it's just y. Yeah, right, exactly. And then we have
4 times squared about 8 squared.
Yeah.
Let me see even. That's gonna be 4
9
is 2
over
squared.
64, right?
Nope.
No, 12 over 64. Sorry.
Nope.
Oh, I'm just really fucking up. 36 over 64.
Nope.
Wait, what? What do you mean? No.
Cancel. Do the cancels. Remember
the
evens?
Well, yeah. And then that's 18 over 32. 9 over 16. 9 over 16.
Yeah,
9 over 16. Okay, cool.
Yep. Wait for you to do that little nice, nice cancel.
Okay, so I think this is the final thing. 9x to the 7th, y over 16.
9 16ths as 7th y. Yeah.
I think that's what we do if we wanted to get to that. Okay, let's do this a quicker way though.
Yeah, I really hope someone has the actual answers for this.
Oh, I'm sure they do. This isn't that bad. So anytime I see to the -2, I'm going to get rid of this and just flip these two things. So that's 3x to the 5th over y squared over 8x squared. And this is
with a tagged on friend as well.
And then I'm going to move this as 4x over y to the 3rd.
Okay.
Right?
X to the 5th, y at 2nd, divided by...
Yeah, it's good. X to the 5th, y, x to the 2nd. This is going to go away, become x to the 3rd. And now we can multiply through. So now this is 4x.
Let me show you. When we put y squared and y cubed cancels, leaving a y on top. That's for the y times on top.
Yeah, once we get that.
Without having to... Yeah.
Okay, so then this goes away. This is just y. This is going to give me x to the 7th, and this is going to give me...
36.
Oh, I forgot to square the 8. I screwed up.
Okay, yep, there you go. That should be 96.
That should be it. And actually, this is called...
Force cancel.
This becomes a 16. Yeah, okay, now we're good. So now that's 9x to the 7th.
The reason we didn't see it earlier is that the 2 squared was eluding this cancels.
Yeah, I see how that works.
There's a set of 2s that needed to cancel.
Yeah. Okay, that's a nice way to do
have
that.
some cancel.
Okay.
Nice and simple.
Nice. All right, cool. Good job, Famish, dude. That was one second. Let me put that. Where is this?
Let me check that on.
Good. Nice.
Let's get on to Josh's.
You're okay, Famish.
Well done.
Bong point Famish.
That happens. For a little bit of a story for you.
What's the story?
If you look back a few days ago.
Mm-hmm. Like within the office hour stuff we were doing?
Within the to the 8th of March. I helped Trumbull with, it was a proving problem, and he got taught an important rule: do not overthink.
Do not overthink. Yeah, it's
because it was a proving problem, and I used a different. Now it was proved up to the A, so a little bit. Keep going up, right there.
Oh, is this one right here?
No, right there. Down a little bit, number 36 there. No, on that page. Up a little bit.
Oh,
36. Down 36.
I got you. This one right here, 36. Prove that if x is greater than 0.
But I showed him how to do it using using. There's a trick of proving that one.
Yeah.
Which is, I can actually prove that by acknowledging crossing points.
Okay. You can also there's a restriction on x here, right? X has to be greater than or equal to 0 just for this, right?
Well, it's obvious, because it proves that if x is greater than or equal to 0.
Yeah.
But the idea is if it crosses, parity changes. If it crosses again, parity changes again.
Yeah.
And the odd thing of this one is it was an instant not going to happen, right? Because firstly, there's no crossing at 0, which means it had to have crossed somewhere after 0. Which it had to cross. If it crossed before 0, if it didn't cross at all, we're good. But this crossed twice. So as soon as it crossed twice, we knew that was already done. it to not be all. So
nice. Okay.
Just don't overthink things.
Speaking of proofs, we just got some web submissions that came in. We got one from Jeff. I love you, Jeff, dude.
Not Jeff.
Not Jeff, dude. Jeff has some good questions. This is not Jeff.
Ooh, I love the second one though. I love that second one though.
Okay, here. Let's maybe do the second one for Koro.
And then before we do that, let's do Adarsh's, because that's the plan.
Yes. What do you mean that's not Jeff? Yeah. Okay, I'll do Adarsh's real quick, and then Toro. We'll do Koro's, because Koro is new. I'm guessing.
And then let's do Shantrets, because I know that those are two easy ones.
Well, here, let's just. Where's Adarsh? Adarsh, where you at?
Just quickly, Shantrix had that question from before, and I was thinking, wasn't there a thing about gift cards?
Oh, yeah, no, yeah. Tier 3 is a video game. Kids always ask me if they can get gift cards. No. It's a video game. It can be GeForce Now if you want, or if you want like a Spotify subscription. I've done that for kids before, but it can't just be straight gift cards, because then people just try to max out $60 in gift cards. No. It's not the whole point of it. The point is, like, you're supposed to play another game. That's the point of Tier 3.
Yeah, and they're all Indian.
And they're all Indian. Yeah, well, I don't know. But.
So this logarithmic is, in a sense, and it's actually not logarithmic.
Sorry, what did you say, Seth?
Sneaky. This logarithmic is actually
this logarithm is yeah.
It's a polynomial.
Yeah. Log. What's up, Mondo? What's up, Mondo? Mondo, Dad came back with the milk.
That's dope.
Anyways, yeah. Whenever I want to divide both sides by 2 here, just to start off with, right?
We have to, absolutely. We can't do anything else but that.
Yeah. I mean, I could raise the 2 over here if I really wanted to. We'd just be kind of like bad.
I'm gonna square root then.
Let me make sure Adarsh is here, actually. Sorry. Let me make sure Adarsh is here. Adarsh, I know he probably is, because Adarsh is great at always being here. That's dope.
Okay.
Oh man, Mondo, when are we playing some finals?
This thing's actually a polynomial. This thing's actually a polynomial.
Yeah. Oh, now Darsh isn't here. Damn it, Darsh, you were just here. You probably just bounced out. Okay.
Give him a second. He's probably here.
I'll give him a second. But also, I like when
we can do his will to activate.
I know Shantrix is here. Yeah, Shantrix is definitely here.
But that should be.
Okay, here. You want to do Cat in the Hat with Shantrix? And then we're going to do Koro. I want to work with Koro. Because...
there's Shantrix.
There's Shantrix. Okay, here. Let's do Shantrix.
You got it, because he's
then
here.
Koro, I'm gonna work on yours next, because I appreciate that you submitted something.
After Adarsh is still on deck as soon
as if Adarsh shows up. Okay, here we go.
Yeah,
all right.
As soon as he shows up, he's on deck.
The cat is in this hat. The cat is not in this hat. The cat is not in hat 1. Exactly one of the statements is true. Exactly one hat contains a cat.
So let me give 2 statements. Let me give 2 ideas here. This is what I know is a treasure chest puzzle. There's a treasure chest puzzle, which is based on this idea. And this is also has a system of knights and knaves. Where knights tell the truth, knaves will always lie.
Knights and knaves? Dude, I haven't seen the word knaves since like
these puzzles come from
Dungeons and Dragons days. What knaves?
Is in the sense it's a logic. It's It's looking for something we call a contradiction.
Yeah, contradiction, yeah.
Assume a state. Yep, that's what it is. Assume a statement is true. Contradiction. Until something must be true.
Okay.
If it doesn't contradict, we have a true.
Yeah, okay. The cat
And
is in
everything else false.
this hat. So if I'm going to assume this is true,
So
right?
let's assume
Well, then this is
assumption
false,
that-
right? So that doesn't work.
that statement 1 must be true.
If statement 1 is true, statement
If
3 is
statement
not.
1 is true, then statement 3 is false, which is fine. If statement 1 is true, if 1 is true, 3 is false.
2
and
could be true.
Now here's the funny thing.
Oh,
2 must
but
be-
exactly
2
one
must
of the
be
statements is true.
2 is also true.
Exactly
1
one
is true, 2 is
hat.
true.
Oh, okay, but this
Which is
can't be
illegal.
true. Yeah, this
So
can't
1
be true.
must not be true. 1 must be false.
So 1, yeah, exactly. Okay, this is cool. Yeah, so we assume this is true. That means this is false. But then here we say exactly
2 is
one of the
false.
statements is true. Okay, so that means this one would have to be false. But
Which means it has to
in
be in
order
2
for this
hats.
to be false, there would have to be a cat in this hat. But only one
fine.
hat can
Just
contain the cat. So,
So statement 1 must be false.
yeah. Yeah, so statement 1 has to
Okay,
be false.
then-
Okay, so we
Now,
that's
the
some
mark
cool logic
statement 1
thing.
is false, because we know that. now.
What's
We
up,
made
Humiar? So
We don't know about
definitely
statement 3
true.
anymore.
Wait, definitely
Nope.
false. Definitely false.
If 1 is false, 2 is false. 1 is true, 2 is true.
Okay, wait. We're gonna assume this is definitely false.
Now 3 we can't assume right now. 3 we can't
Okay.
assume is false.
All right. Wait.
Let's assume that 2 is true.
Wait, one sec. The cat is in this hat. So the cat's not in that hat.
But 2 is true.
So that means this is true. That means 3 is true, no? Because the cat is not in hat 1.
Well, it's a trap. This is a little trap because if true is true, which we're assuming,
If true is true.
true.
Sorry, what?
If 2 is true, then the cat must either be in 1 or 3.
Uh-huh.
But 1 is false.
Correct. So it has to be in
The
3.
cat must be in cat 3, making
Okay.
3 also false.
No. Give me
Which
one
is
second.
fine.
One second.
Which is perfectly fine.
Is it not just faster to write a logic table for this?
Oh, maybe. I don't know.
No. And then that is it. Well, so if 2 is true, then 1 is false and 3 is false, which is perfect.
Just definitively no.
No
Just go for
contradiction.
yourself. Yeah, thanks for that.
Yeah. So wait. Sorry. If 1 is, we already proved 1 has to be
It's
false.
true. If 2
If
is
2 is true,
1 is definitely false because of earlier statements.
well, okay. If 2 is true, 3 is true as well. Then
3 is false because. Oh yeah, 3. So 3. Yeah. If 2 is false, if 2 is true, 1 is false.
we already
said
said
it's
we
not
already
in hat
assumed
1,
we already assumed 1 is
which was
false.
not illegal.
1 has to
Could
be
in-
false.
3 could be false. The cat could be
Mondo.
in hat 3.
If 2 is true, then 1 can still be true.
Exactly. But no, 1 has to be false though.
We already proved 1 has to be false.
That is not in hat 1.
Yeah, 1 has to be false. That's what we proved earlier.
If
We
2
said
is
assume
true,
assume
then
1
this
is.
cat must be in hat 3.
Slow it down and draw a diagram. I agree. I'm hearing like too many cooks. I don't know what the fuck's going on. Okay, here we go. One sec. Okay, I'm gonna do this. We're gonna say statement 1. What was it?
You're
We'll say
doing too much
1,
writing there.
2, 1, 2, 3. Okay, I'm gonna assume that this is true. Just watch. Okay, this is true. The cat is in this hat. Cool. That means the cat is not in hat 1. That would have to be false. Or wait, no, yes, that would have to be false. Okay.
We're illegal right now.
Then this is already illegal
No,
because
3 must be true if 1 is true. No, sorry, 3 is false. Oh yeah.
no.
This is not.
Once, yeah. Chill.
Okay, not.
1. Okay. If 1 is true,
Two is
if
true.
the cat is in this hat, then 3 is false because the cat is in hat 1, right? And then 2 could be true. 2 could be true or false. Okay, but then here's the statement. Exactly one of these statements is true. So this is the
Which
only
is
one
fine.
that can be true. So this one has to be false.
And then
Okay.
now the exactly one hat in the cat goes off. This is illegal now.
Exactly one hat contains the cat. Well, isn't that true then? Because
One is
only
true, then the cat is in hat 1.
Oh,
And
which
in
that's
2,
fine.
Because in statement 2 being false.
Well, that's fine.
Tap error dots. Can't have that. 2 must be false. If 1 is true, 2 is false. Yes.
The cat is not in this hat. One sec. The cat is...
We're assuming...
Oh, the cat is not in this hat. Okay. Yeah. Sorry, it is a double negative. So, yeah, if this was true, then you would have two... You'd have 2 cats. You can't have 2 fucking cats. No. Okay. Cool. All right, so this is, like, not possible. Okay. So that tells me right away that 1 has to be false. Yeah, exactly. Yeah, I agree. Yeah, this would have to be true, false, but this is not okay. Okay. All right, the cat is in this hat is false. Okay, cool. That means this is true because the cat is not in hat 1.
Well,
okay.
We don't know that.
Well, no, because I said this was false. If this is false, the cat is not in hat 1, so this is true. Okay. All right, now for statement 2, the cat is not in this hat.
Oh, we just got it. 2 is automatically true. Is automatically false.
Yeah, 2 could be true. Well, no, 2 can't be true because only one statement, so it has to be this one. Okay, so where's the fucking hat? Where's the cat? Oh, so the cat's in hat number 3. Okay, so this is like cat is in 3. Okay, cool.
So answer B is the correct answer.
Cat's not in 2. Cannot be in 2.
It must be in true. It must be in 2.
Oh, wait. Dude, these double negatives keep fucking with me, dude. Wait. The cat is not in this hat. Okay, cat is in 2. Cat is in 2. Okay, thank you. All right, cool. Wait, and that's it? That's done?
Yes, we're done.
Oh, okay, cool.
We forced 1 and 3.
Motherfucking cat in the hat. He's in fucking hat number 2. Congrats. Cat is in hat 2. Yes. Thank you, Kasha. Yep, you got it.
A dash.
Damn.
There's a dash here then?
Adarsh is here. Yeah. Okay. Adarsh, here, let's do your question. And then I want to work with Koro. Use proper notation, it'll help you. Yeah. Yeah, we could get into like what logic notation is.
So there's Adarsh here then?
Adarsh is here. Yeah, he's here. We're gonna do his right now, and then
we can do his then.
And then I'm gonna do Koro's. Yours is next. I know Koro's in the chat somewhere. You can't choose more than one option though. Oh, whatever.
We didn't.
I'm done with the cats. No more cats. No more of these fucking cats.
How we go to...
Here, this is Adarsh's. There is not enough information. Yeah, teachers are the biggest fuckers when they do that. When they say, oh, there's not enough information in the question. I'm like, it's your fucking job to write the question. Make sure there's enough information in it. It's not my job to analyze if you wrote the question wrong. I get so mad at teachers that do that.
As we said, this Twetson... Now that Adarsh is here, this Twetson is a polynomial.
Yeah, so here's what we're going to do. We're going to divide both sides by 2 first. Because I don't like this here. Go away. Okay, so now we get log base x plus 4, 2x squared plus 16.
You can't divide by log x plus 4, though. That's illegal. Technically.
Well, okay, one sec. Okay. I'm going to convert this to exponential form, which is going to be this to the this power equals this.
Traits. Hey, nice.
So 2x squared plus 16 is equal to x plus 4 to the second.
Before we do the square root of that thing, what are the factors of the left side? Because I have a feeling this is going to be that's a nice factor on the left side there.
It might. We'll see. X squared plus 8x plus 16.
Yeah.
So right off the bat, I see this going away. That's nice. That's just x squared. 16 goes away too. So I get x squared is equal to 8x.
Which is not illegal, so we're fine.
So x equals 0.
And what?
Or,
is there another answer? Yes.
X equals 8?
8.
Wow. Okay.
Now check, because there is either of the illegal answers.
2 log base. Well, everything here is greater than 0, which is okay.
Does it work out though? If we were to put it in,
yeah, we'll see it.
2 log 12 of 16 is 4. Is that true? Is log 12 of 16 2?
Sorry. That's
128
plus 16. That's 144. Equals
is that
4.
True?
Yeah, that's cool. Because this is 2, right? Because 12 squared equals 144. Yep. That's the other way to rewrite this, Adarsh. You can write this 144 as like 12 squared. And anytime you have the log base of something else, they cancel out. This goes away.
And then what about 4, 8?
Solve in C, please.
8.
Excuse me? You want me to write code for this?
What about 8?
Well, 8 worked. We just tried 8. We just tried 8. No, we should do 0. Yeah, okay. So 2 log base 4 of 16. This is the same thing, because this is 4 squared. Is equal to 4.
Lovely.
Yeah, that goes away.
There are
Cool.
2 answers.
Nice. 2 answers work. 0 and 8.
Which if you draft this thing, will tell you if you draft the left side and right side, it should be true.
You can use a calculator to plug it in. My teacher said to plug it in the x value with the equation in the calculator. Yeah, you could. I think it's cooler though if you know how to do this without having to.
So if you Desmos this to chat, you can.
You could.
Chandrats. No.
It's super really not needed though.
No.
Just no.
Not don't have to decimals. Ugh.
Yeah.
Yeah. Solve in base 16. Go for it.
Yeah, the cooler way to do this is not to use your calculator. It's to understand that, oh, if I plug this in, I get 144, which is 12 squared, and the log base of the same thing, this cancels out. And that's how that comes down. I actually had a good explanation for this one. Remember, Seth, we were kind of like struggling to do this one. To show, for instance, why A log base A of B is equal to B.
Once I remember my proof roll.
Yeah, so this is the way I wanted to write it. Let's just say that log base A of B is equal to log base A of B. Okay?
Duh. You mean
right? Yeah,
second.
duh. Like 1 equals 1. Now, by taking this into exponential, right? That's like saying A to the this equals this.
You're repeating my information again.
Oh, is it? Okay, well, I rediscovered it for myself. This is Buddhism or something.
That's what I attempted to do. I just...
This is cool because this goes away. Yeah, and you just get,
I just did not exponential. Which is what I did at the very beginning. I said, let's put this in logarithmic form.
Yeah. Or exponential form. Don't put it in logarithmic form. Put it in exponential form.
Solve in exponents. Put it to logarithmic, and then I'll solve. And it's
yeah.
Gonna get that same.
That's pretty cool. We solve for x, then we plug it in. Yeah. You still have to do the algebra to solve for it, but the checking it, you could put it back in the calculator if you want. But I think it's cooler to put it in and then see how these rules kind of work. I don't know.
Okay.
Don't get too reliant on the calculator. It's cool, but a lot of the beauty in math from canceling things and, you know, like the cool tricks, the calculator tends to hide, you know. You just get right to the answer. You get to the point.
The second one that was given, before we go on to the next one, I want to show you an interesting math thing that occurs.
What's the math thing you want to show me?
So, write this out and you'll kind of see some things. You can just write it out on an empty page if you want to, whatever.
Okay, what's up?
And then that is what let. So this is a let. This is an untrue statement, but we're gonna let it happen, and you're gonna enjoy it. Let
like
1 equal 2.
Let 1 equal 2. Uh-oh. I don't know where this is going.
Disqualified!
1 plus 1.
What is 1 plus 1?
Based on that statement.
Yeah. Then 1 plus 1 is equal to 4.
No. You know why? 4 is 1 plus 1 plus 1 plus 1.
Well, but I thought 1 was equal to 2.
Plus 2 plus 2 plus 2. What actually happens is 1 plus 1 equals 2 to the n.
1 plus 1 equals 2 to the n?
It equals the series described as 2 to the n, because it can be any number that's a power of 2. Because 1 plus 1 is 2, and 2 is 1 plus...
This is a Terrence Howard proof? Oh, God.
Which becomes 2 plus 2, which becomes 1 plus 1 plus 1 plus 1 becomes 8 2s, etc., etc.
Oh, I see. Okay.
If we said that statement backwards...
Yeah, don't do this at home, kids. Stay in school.
Yeah, if we do it backwards, we get modular.
Yeah.
Which is the interesting thing. If we said let 3 equals 0, we get mod base 3.
Oh, I see. This is how modulus works. Okay. That's cool.
In the backwards way. No, this is series. Or if
I
we
see.
Let a small number to a bigger number, we get a series, which is kind of funny. So, which goes into the next question. So, heat.
This one? Induction?
The second proof. The second one. The second one's one I know. I know an idea what I want to do with it.
Who is this? Koro? Koro asked this question on our...
so I care about the second one there. That's the one I'm worried about.
Kat's asked a question too. What's up, Kat?
The first one is something is going to be matrix. The second one I have an idea though.
prove by induction that n is a positive integer? Is that what they're saying?
Well, no. We know that for n being a positive integer,
Yeah.
f of n equals 4 to the n plus 1 plus 5 to the 2n minus 1. That's divisible by 21. That's our
Oh,
job.
sorry. So you're talking about this one?
Mm-hmm. That's the one I think you haven't yet, because I see divisibility rules again on that one.
All right. Okay.
And more importantly, modular arithmetic.
I need to get better at modular arithmetic, honestly.
Yep.
So what? This is like 4 to the n. 4 to the n times 4.
Nope.
No. Okay.
Yep.
It says no.
There you go. 4 to the n. That's fine. You can break that if you want to.
Times 4 plus 5 to the
Plus
2n
5 to the
over
2n.
5.
Yeah. So modular, because we want to prove that it's divisible by 21. It has a factor of 3 and a factor of 7. So 4 to the n plus 1, it's just going to do it at 16, right? And it's going to, that 4 to the n times 4 stuff, it's going to start as an integer, which is which is a positive integer, though.
Mm-hmm.
It's going to start at 16, and it's going to do times by 4.
Well, positive integer means it's going to start at 1, not 0, right?
Well, it's going to start at 16, though, because...
the whole thing starts at 16. Yeah, okay. I see.
I wouldn't worry about doing.
Sure.
And then the other part, that thing, when we start it, must start at 5 and go
Correct.
But not straight in powers. It multiplies by 25, and then it jumps.
Oh, I see. You want to write this as like, instead of 5 to the 2n, I'm going to write this as like 5.
The notion statements.
5 squared to the n. That's kind of what I'm writing, right?
Well,
5 squared to the n.
I'm just doing notion statements. This is what we know.
Okay.
It's a weird one. I know
this is 25 to the n, right?
Nope,
that's what 5 to the 2n is, isn't it?
It's a power tower. That's also illegal.
A power tower?
Power towers say take from the top down.
So wait, 5 to the 2n is not the same thing as 5 to the second to the n?
That is, but it's not. In power tower formation, you must go from the top to the bottom. So 2 to the n must be done first.
Well, can I just like switch them or something?
It's not. Power towers do not like that move. You want to give me an example?
Oh, I see. Because of the -1. I see. The -1's fucking it up. Oh, I see. Okay.
A little bit, not just that. If you did 5 squared to the n, do that for 3. So I think that's where it's in a break. It's going to be illegal.
I see. No, I see what you're saying. Okay.
There's 5 to the 8.
All right.
It doesn't equal 5 cubed.
So usually by induction, though, I have to come up with one case that I know is correct, and then we have to do to the n plus 1 and show that that's also correct, right? So
I don't necessarily know induction, but I'm trying to.
This is well, okay, yeah. So yeah, so well, I mean, that's the whole point of this question. It says prove by induction. Okay, how you prove by induction is you show one base case that works, and then you prove that it works for the n plus 1 case, and that means it works for any case as far as we go. Okay. So when I see stuff like this, I think what I really want to show is that like 4 to the n plus
either 2n minus 2 is the only option.
Do some epsilon delta. Epsilon delta? No, I don't want to do epsilon delta. Excuse me. I'm talking about for derivatives, dude. Chill, dude. What?
Obviously, don't go and do that.
You do it.
Yeah, don't do that.
Problem.
Okay. Here's how I think I want to write this. One sec. I need 2 times n plus 1 to equal 2n minus 1. So this becomes 2n plus 2. Give me a second, Seth. Give me a second, Seth. 2n plus 2. So one sec. So I want this to be 2n. I think I want this to be 2n minus 2.
Why are you saying that 2 times n plus 1? That's just a statement that's not.
Well, because I want to show that if I increase by n plus 1, I get to what I want.
That means that 2 equals -1. Which is illegal.
Wait. Just wait, please. How am I gonna get to 2n? That's gonna introduce a 2. So I think I want this to be 2n minus 3. I think that's what I want this to be.
Well, that's we maneuvered stuff
yes,
that you're not allowed
yes.
to
I want this. This is what I want. That's what I want. I want this. I think I remember. Okay. If I can show that this works for some value of n, and then I just gotta show it works for the next one.
That doesn't work because 4 to the n plus 1 plus 5 to the n 2n minus 2 is true of this. If I added 1 to the powers again.
Yeah, well, look, if n becomes n plus 1, then I get my original statement here.
Well, no, because the other side isn't. 5 to the 2n minus 3, where n is... Oh, okay. What?
No. I have replaced n with n minus 1. Correct. Yes, that's what I've done.
Okay.
Yeah.
Start with n equals 1, okay. So
Just start with n equals 1.
16 plus 5 is 21. That's fine. Yes, n equals 1 is true. N equals 1 must be true.
Yeah, okay, that's right. Okay, 4n plus 1 plus 5, 2n minus 1.
I might have a way. Let me ask you the following. Because this is a function, right? If you know this is a function, based on the rules. So, f of 1 is 21. What is f of 2?
So here's what you want to do. Okay, we've already proved that this is divisible by 3 and 7 for n equals 1. So now what I do is I just replace n with n plus 1. So this is for n plus 1 plus 1. And then I say plus 5. And then we say 2 n plus 1 minus 1. So watch. This becomes 4 to the n plus 2 plus 5 to the 2n plus 2 minus 1. So that's going to be 2n plus 1.
Which is what we had to start with, which is...
No, because we had 4. Okay, now watch what happens. This is the same thing as 4 times 4 to the n plus 1.
Alright, assume true
Plus-
for n equals k, 4 to the k plus 5 to the 2k minus 1.
Exactly. Yes,
M,
yes, yeah.
Then show true
And
for
show-
n is k plus
Yeah,
1.
yeah, he's right. So we want to try to make this look like what our original statement was, because we know that that is divisible by 21. And so in order to get 2n plus 1 to look like 2n minus 1, that's the same thing as 5 to the negative 2, and it's 5 to the 2n plus 1, right? Yes.
But that's not help, because...
No, wait. No. It's 5 to the 2. 5 to the 2. Sorry. And then this is 2n minus 1. Sorry. This is what I meant to say. Okay, cool. All right.
There's your does statement. Now what?
Well, so this is our original function, which we're cool with. So you kind of want to show that this multiplying by is just going to introduce more factors of
Well, it's not.
of 21.
That's 29. If 4 plus 25, it's 29. 4 times something plus 25 times something.
Yeah, let me think about this.
Let me go
You could
back to
try
my other-
subtracting.
Let me go back to my other thing first, and then I'm going to ask you the following. This is a function. I know it's a function. Just write this out so we have these, and we'll see if anything happens. If it doesn't, go back to yours.
Mm-hmm. What's up?
So we know this is a function. F of 1. Just write it as function notation for me. F of 1 is 21. We know that. What's F of 2? Let's see if something starts to happen or not.
Well, I know it's going to still be divisible.
What is F of 2?
That's
If it's divisible, we have
64.
a hopeful statement.
It's 64 plus 125. So what's that? 189?
Yeah, is that divisible by 21?
Yeah, because it's just this times 9.
Okay, that's how. Okay, that's times by 9. What's F of 3?
It's probably at times 9 again.
Well, that's what we hope. That's what we want. And we have a proof.
Well,
We
no.
have a start
The
proof.
proof is we have to somehow pull the 9 out of here. We got to show
What
that.
I'm saying is we have an idea of what this is going to happen.
I agree. It's not a bad idea.
That's why I'm-
so
that's why I'm
4 to the
hoping it's gonna be
4th
by 9.
is 4 to the 4th is 256, right?
4 to the 4th is 256. Yep.
So we have
That's 2D,
256 plus 5 to the 5th, which is ugly as
That's
fuck.
that. I do know 5 to the 5th.
Oh, you do? Or what is
I
it?
get 10 I know 5 to the 4th is at 25. As I say the numbers.
What's 5 to the 5th?
3125.
2125?
3125.
All right, so 3125 plus 256. Ew.
Yep, it is 3381. Woot! That's divisible by 3. Woot!
3381.
That's divisible by 3. So
wait, but I want to see what the difference is here. This is a times 9. Is this times 18?
Let me see.
I think it is.
Let me do. It can't be times 18. You know why? 9 times 8 is 2. Has a 2 ending. Can't. 3381. That's a 3 does end 1 1.
Oh, it's not.
It's
damn.
What is 189 times 9 though?
Damn, it's close. It's not a rational divisor. You're right. It's not.
Oof. Okay, so we just said
that's annoying. Okay, so I don't think we're gonna pull anything nice out then. This is annoying.
F4. Just gonna do one. Just gonna do one more. See if it does anything. Because I don't want to go 2-bit. It's just gonna get worse.
I think we're already done at F of 3. It's too much. It's too much at this point.
Is 4 a problem already? 4 to the 5th isn't though, but the other one might be.
Yeah, the other one sucks. I just don't want to do it.
No, that's 9.
Where do we pull this out?
Don't want to do 9. So that wasn't help. Now that did the opposite of what I expected. It did something. It said, well, it multiplies by 9 and then it does something yucky.
Yeah. O'Mady says, can you explain the law of sines? Yeah, I got some videos on it. I totally got some videos on law of sines. If you haven't found our TikTok yet, let me show you too. One sec. Ooh. The best way, O'Mady, for you to get help with specific things is to submit a screenshot to the thing we have down here. Otherwise, I have it. I have a video on it. You should just watch the video.
Is it?
One sec. Where is it?
Though.
Here, law of sines.
Here's how to use the law of sines.
Yeah, go use this. That video is great.
I did it interesting though. The multiplication is 17 8/9.
Sorry, what?
The multiplication between f of 2 and f of 3 is 17 8/9.
Okay.
No, between f of 2 and f of 3.
When it says, look at the powers of 4 and 5 mod 3 and 7.
F of 2. F of 2 times 17 8/9 is f of 3.
Yeah, okay.
You notice what I noticed? It's 9ths.
No.
It's 9ths.
Okay.
So we still have 9s involved. It's not the most helpful, but it's there.
It's really not.
Well, 9ths are there.
Look at the powers of 4 and 5, mod 3 and 7.
Modular, please. Yep.
I hate mod rules, man.
It's easy, though. 4 is 1.
Uh-huh.
4 mod 3 is 1.
Yeah.
16 mod 3 is 1.
Okay, so they're all just 1.
30. Is it? 64 mod 3 is 1. Yep, it's 1.
No offense, but I'm not sure using clever tricks is the best way to teach students induction. Induction is fairly straightforward. How is it straightforward, Jeff, here?
4 mod 7 is 4. 16 mod 7 is 2. 64 mod 7 is 1. And it's going to repeat the 4-7-1 pattern again.
Well, what's up, Frisian? All right, I'm gonna give this one like a couple more minutes and I'm dropping it.
Why?
If I don't,
we
we got to move forward on questions. I'm not gonna.
No, you don't.
Not gonna burn.
You got right now until
No,
the other person shows up.
No, we got a lot of other questions coming in. Set f of n equal to 21m since it's divisible, multiply by 25 and then reorganize some. Okay, Endar's got a good idea here. I kind of like this. Set fn equal to 21m since it's divisible by 21, multiply by 25 and then reorganize. Okay, let's try and do that. For the n plus 1 plus 5. I've lost brain cells for looking at one number. Yeah, I know, guys. It's okay. I'm going to work on this one for a little bit more time, then I'll work on some other stuff for you guys. Okay. multiply by 25. Okay, so you're saying multiply both sides by 25? In induction, usually f of n and show for f of n plus 1. I agree. I mean, that's what we were doing. But you want to see a pattern. With induction, you usually want to see that the thing from before happens
we do
again.
see a pattern.
Okay. So then this is 5 squared, 4 to the n plus 1, plus 5 squared, 5 to the 2n minus 1 is equal to 5 squared times 20. So 5 squared times 3 times 7 times m. I'm just curious what you guys are seeing. Reorganize. What am I reorganizing here? Replace the first 25.
Yeah.
Oh, yes. This is the trick. This is the trick. Yes, No, Endar, you're so right. Thank you, Endar. That's the trick. That's the trick I forgot to do. You have to write these numbers as additions of things, okay? So instead of writing this as 25, you have to write this as 21 plus 4.
Remember that nasty problem I got to show you?
Yeah, now I remember this. Okay. Yeah, uh-huh.
With Woody, my friend.
Yes, yeah, okay. Okay, and then this is the same thing as 21 plus 4. Uh-huh. Okay, well, this is obviously divisible by whatever. Okay, so then this is 21. That's too funny, man. Really?
What?
Fine. It's so funny how this works. Okay, plus 4 to the n plus 2. Plus 21 to the 5 to the 2n minus 1. Actually, ooh. Yeah, I want to change this one, right? Yeah. Wait a minute. Second one, stay 25. Yes, exactly. Yeah, I want to keep this as 25, right? Yeah. Because now this is going to be 5 to the 2n plus 1. Right? Is equal to 25 times 21m. Okay. Yes. Okay. And then
Uh-huh. You got a problem?
one sec. I want to go back to showing this happen somehow, don't I? I have this. Why do I want 2n plus 1 to the power? Oh, okay. Yes, okay. Got you. Okay, watch. So 4 to the n plus 2 plus 5 to the 2n plus 1 is equal to 25 times 21m minus 21 4 to the n plus 1. These things are obviously factors of 21. These are factors. Okay, I got you. Yeah. Okay, cool. So this will have to be an integer. Times 21 means this is also divisible by 21. And so since we've shown the n plus 1 case works, because that is what the that's what the n plus 1 case is. This was the n plus 1 case.
What about the function case that we said that 4 to the n plus 1 plus 5 to the 2n minus 1 something?
Yeah, that's fine. That's the original one. We already showed this is true. We already showed this is true for n equals 1. So then we have to prove that it works for n equals 2 for n plus 1. So
which we did.
Throw the first term on the other side with the other shit that is divisible. Yeah. Right. Yeah. Yeah, you just put this over here. And now all of these things have 21s in them. And so whatever this is, times 21 is divisible by 21. And this is the n plus 2 case. Okay. I got it. Cool.
You said you were going to give up on this one.
Well, until Endar gave me the secret key for it. I said I'd give like 2 or 3 more minutes for it.
Now let's do the matrix. That's another proof of induction. Then I'm not that.
Well, let me do someone else's question first, and then I'll get back to this one because I don't even know if Koro's here. Koro, if you're here on the chat, say hi. Otherwise, we just spent a little bit of time on your second question, which this one was done. Cool. Nice. That's a fun question. I like that one. Here's my clap.
Okay, So we have a new problem, and you guys have.
Yeah, cat. And then Jeff, I will do your questions. I do like your questions, Jeff.
Not Jeff.
The is not Jeff. My language, yeah, that's cool. Yeah, proof by induction. Okay, so the main thing that I want to maybe emphasize. I know, Jeff, you say like proof by induction sucks, just like giving a bunch of tricks, but the same trick just keeps popping up over and over again. And the trick is that when you write out like this thing here, you want to try to write it out in terms of the other number there, right? Which is like 4 plus 21. You want to write it out as like what one of the other factors is in front, and also by what the thing you're trying to prove is it's divisible by. This trick it happens so much. Yeah. Oh, doctor. Yeah, I got you, Adarsh. You're good. Or did I? Oh, I gave one to Shantrix. That's what I did. Yeah, you're fine. Okay, fine. There you go, Darsh. Okay. Let's see. Next question was from Kat. Kat says, a company produces steel rods. The lengths of the steel rods are normally distributed with a mean of that and a standard deviation of that. For the shipment, 29 steel rods are bundled together. Find the probability that the average length of a randomly selected bundles is less than that. Cool. This is a, well, 29 rods. Still decently high number. And we have... Oh, this is the population standard deviation. Yeah, so whenever this happens, this is the population standard deviation, which means we can use z-tests. If we didn't know the standard deviation, then we would have to use what's called like student's t-test to do this type of question. But, okay. Z-score is going to be equal to 186 So this here's the equation. It's x bar minus mu over sigma x over the square root of n.
X bar is what?
X bar is what the mean of your sample is, which in this case is 186.6. Mu is the mean of your population, and they say, oh wait, no, sorry. No, sorry, I have them backwards. This is what you're looking for. X bar is 186.3, because that's the sample you're looking at. You want to see what's the probability that some sample I take is 186.3 or less. Mu is what they say the population mean is, which they don't specifically say the word population here, but they say a company produces rods and the lengths of the steel rods are normally distributed with this mean. This is assumed to be like the population mean at that point. And they also say what the standard deviation is. They're not saying the standard deviation of the sample, they're saying of all the rods. So that's why we say that's the population. And then the 29 is the sample size, that's n, so this is square root of 29. Cool.
And then we can just solve this time for z.
This is easy to solve, yeah.
Well, the square root of 9 is zeros. But...
yeah, it's just 3, yeah. But I need my calculator for the other parts. One sec.
Yeah, 0.3 divided by 0.3 square root of 29 divided by 1.3, 313 square root of 29. That help?
Yeah.
313 square root of 29.
Well, yeah, it's 0.3 over 1.3 over... Wait, what? Square root of 29 is not a nice square root.
313 square root of 29. I didn't take the square root. I just
oh, you haven't done the square root yet. Okay, whatever. I'm just gonna...
square root.
At this point, like, stats is one of those classes where you're allowed to use the calculator. You are most definitely allowed to use the calculator.
39.
Yeah.
Well, that's duh.
Yeah, don't feel like you need to do like math in your head in stats. You are totally allowed to use a calculator. It's a very calculator-heavy class.
You just made it harder on
5.
yourself.
Did I?
Yep. You know why square root of 29 is that number? What is this stuff?
Oh, sorry. I have to do this divided by this. My bad.
No. Well, you already messed up. So you have to do it again because it's gonna round it now.
It's okay. It's close enough. 0.043. That's a very low z value. That's a very low z score.
That's not the probability though, is it?
It's not. That's just the z score. But it's basically 0. I would say the probability here is basically 50%. But we can see what it actually is.
13 13, 313.
Is stats good? Stats is great. I actually love stats. I think stats is one of the most important classes you can take in high school. But here, you can do what's called, I want to calculate, how do I do this?
Did I mess something up?
Oh, it's under distribution, sorry. It's second distribution, here we go. And then I want a normal PDF. And then the X value I'm going to use here is, no, I want CDF, sorry.
You might have messed. I don't know if I feel like you messed up, but
Well, actually, this is negative. My bad.
yeah, negative
Yeah.
1.24 is the z-store.
Really?
You divided by the square root when you shouldn't have. And
I selected AP
when you
stats.
divide
Yeah,
by a
that's a great
fraction,
one.
You multiply by its reciprocal. Remember that?
Oh, you're so
didn't do
right.
that.
Yeah, I fucked that up. My bad. Okay, sorry.
So I'm gonna do that again.
Alright.
That was wrong. I kept it.
No, you're good. You're good.
No,
No. You're right. I got ahead of myself.
it's negative 1.24 if you care.
That's a much better z value. So divided by 1.3.
Wrong again. Wrong. Sorry.
No, just give me a second.
183.3 minus 186.6 is
Oh. Okay.
Right.
Yeah.
We don't care if it's negative 3.3. We care about it's
Yeah, no,
negative-
it's the.
no.
Yeah, I put the long one. One second. 186.3 minus 186.6, negative 0.3. Cool.
There we go.
Divide that by 1.3. Cool.
Yep.
And then multiply it by the square root of 29. That's what I wanted. Okay, negative 1.24.
better.
That's a much
Much
better
better.
z value. Yeah, otherwise I was like, this is dumb. Negative
We're
1
doing
point.
it. Is that
Negative. Yeah. Okay. Cool. All right. So then, if you go to distribution, so there's two ways to do this. You could go
I had the
to
full
a
number
Z-
in case it does off.
Z table. Z tables are
Sounds
cool.
correct.
I think kids should know how to use Z tables. I'm going with this one.
And use that one. That's a pad. There.
It's a great table. Not this question. Okay. Negative 1.24. So
2.4 with that's other places. Rounded wise is negative 1.4. But
this is going to be negative 1.2. And then the negative 1.24 means I need the 0.04 column. So then this is your answer.
it is not. It doesn't go any further at least, which is
Yeah, 0.1075. Yeah.
which is
Okay.
not correct. Nope. Don't agree.
Well, we haven't rounded it yet.
Read it. Yep. There you
And then to two decimal
then-
places, that's going to be 0.11. Cool.
0.11 what?
What is 0.11?
It's probably isn't it a unit or something? Probability wise,
No, you can just leave it as a decimal.
like percentages or something.
It's
like
I mean it's technically 11%, but in stats when they ask for p,
Wait,
you can
what?
just you when they ask for
What is
p, they just want it as 0.11. That's what they want.
11 point what percent?
No, you don't put the decimals for that. We already did the decimals in this.
Well, you
What-
change percent then
Nice.
round, but
No.
Is that
You
what
just
we're done now?
you just in stats you don't write percent. You write 0.11. That's what they want.
no.
Yeah, that's just how this class works. I agree it's
Yeah.
11%. How do I sign up for your tutoring? Well, you can
You
just join
don't.
our Discord if you want. It's free. And then you can also submit questions using that.
So if Toro is not here, we have a question from not Jeff.
Not Jeff. Get in here and learn some sweet FA. What's the FA sensation? What are you saying? Sweet FA, what's that?
Fuck all.
Sweet fuck all. Yeah, I feel you. Okay. Let's see.
That's the last question, other than if we want to go back and do others. If
What? Who?
Swa
Koros?
or
Koros?
Taro is
Where?
here.
Where is Swaha, dude? Where's this boy Swa?
not here,
Swall dog, you submitted
check.
so many questions, Swa. Where are you?
not here.
You like? I can't believe this student spent this much effort taking this many
I
screenshots
know-
to
I know
drop
how to
them in
do
here,
4 of those.
but then
At the
doesn't
minimum.
show up for us to actually go over the
And I
question.
love some of those. I like some of them. So
One
we
sec.
have
One sec. I gotta check my
have-
phones. I have a friend flying in from Japan right now.
Is Tara here? Is Tara that person here?
Okay, cool. Sounds good.
Listen, wished.
Yeah, one sec. Here's my address. You wanna stop by? Okay. Alright, let me see. Alright, I don't see Swa.
Is Tara here?
I'll try. Well, we can try Cora's other one because do you know how to do this one? His first one.
It's
we're gonna figure it out.
I've been into Ontario.
What, you don't like matrices? Matrices are great, dude.
No. But I know someone else that we could help with maybe.
Oh, Jeff. Wait, we gotta go help Jeff.
Yes,
Jeff.
that too.
Jeff. Here we go, Jeff. Okay, we're gonna help Jeff out. What is the angular diameter of Pluto as viewed from Earth? Oh, cool. So, my trauma. Yeah. So, angular diameter has to do with, like, if you're here looking at the stars, there's a certain amount of degrees that you would measure the width of something being. Yeah. So,
But we don't know anything about it.
that's called... do they call this angular diameter? I would say, like, the angular resolution is what I would say, maybe. Is it called angular diameter, Jeff? Or I would say the diameter in degrees, maybe. Okay. Oh, it was Kasia? Nice. Yeah, Kat, did that make sense to you, by the way? Thank you, Kasia, for your question, Kat. Yeah. Did that make sense how we did this question for you? You could have also used your calculator to do Z-table stuff, but yeah. Solid angle. Is it called solid angle? One sec. Let me see this real quick. Oh, it is called angular diameter. Yeah, this is a much better picture than I could have drawn.
Angular diameter or apparent size. You should have just said apparent size, yeah.
No, apparent size is
esoteric motherfucker.
He is esoteric, dude. Or Jeff's cousin. Or wait, sorry, this is off. No.
Jeff's sister, Beth.
Beth. One sec. Can I just copy this image, please? There we go. Nice. Okay, cool. Yeah, this one's great. All right, here we go. Yeah. So they call this arc minutes, arc seconds. It's so interesting how degrees, when you start getting to finer versions of degrees, starts going into like seconds and minutes. And I want to say there's 60. Is there 60 minutes in a degree? Or is that how it works?
Yeah.
And it's 60 seconds per minute?
Yep.
It is 60 minutes to a degree. Yeah, it's super weird. It's like, why did we just start using time all of a sudden? Like, what? Cool. Yeah, you're welcome, Kasia. Yeah, Kasia, the hard thing on that question is always realizing which test to use. And usually having some sort of flow chart to just describe, oh, do I have this? Oh, do I have this? What do I look for? What do I look for? Yeah. It comes from the Greeks. Okay, cool. All right. The diameter of Pluto is viewed from Earth. I need to remember what the equation for this is. So let's look up. I want to say it's something like... It's just a triangle, isn't it?
Probably. It's probably a rectangle if I had to think, but I don't know.
Sexagesimal? Dude, what type of kink math is this, dude? Macbeth, how old are you? Oh, okay. Oh, wow.
The height divided by distance.
I'm almost
90 years old.
Yeah. Did you see that, like, what was it? J.R.R. Tolkien died in 1973, and it's like 1 ring to rule them all, 9 rings for men, 7 for the elves, and 3 for the dwarf kings, or something.
I remember the movie. I've never seen it. I've never read the book.
Oh, it's great, actually. It is just a triangle. Yes. Wow. Thank you, Macbeth. Yes, I will drink some coffee, just in your honor. Okay. Good old base 60. Based. Okay. So yeah, angular distance is... Yeah, this is cool. For small angles where D is much greater than D.
Yep.
Do you know why this is? Actually, this is kind of fun. It has to do with if this angle is so small, then the small angle approximation says that the sine of an angle is basically just that angle.
Jeff,
This is
yes?
Yeah. This is a big physics
Oh,
assumption that we use all the time.
the
Schmol.
true equation then. True
This is
formula.
Schmol. Yes. So that's why, right? And remember that the sine of theta is equal to the opposite over the hypotenuse. So that would be d over big D. And then again, if this is small, we just call this theta. The exact is 2 times arc sine of d over 2. I agree. But I think the angle is going to be so small that we're allowed to just do it.
Let's do it both ways and see what happens. 'Cause it's
Okay, sure, we
fun.
can. That triangle is technically not a right. Yeah, this one is not. Yeah, this is actually a terrible diagram because what we should be doing is we should be doing like this. The problem is like the eye, right? The eye sees kind of like this, I guess. Is that why we have the factor of 2?
The 2
Right.
times
I think this is the diameter. So this right here is d over 2, and then this right here is theta over 2.
That's also why there's a rule about mirrors. You only need half the mirror to see yourself.
Yeah. Okay, so we can use the exact one. So 2 arc sine of d over 2. Wait, but I need a distance in there somewhere.
Yeah, you don't know the distances. That's the fun part, right?
Oh, this is the diameter. My bad. Got you. Cool. Yeah. Okay, cool. Yeah, d over d. Yeah. Okay, cool. Is this so? This is the distance, but wait. So how far is Pluto from the Earth? We gotta look that up. No, my bad. Getting used to this foot pedal. Okay, distance of Pluto to Earth in, I want to say meters. 4 billion miles. Or we can say in miles. Let's just see. You're close. 3.3 billion. Okay. So this is 5.
AUs is it?
That's a good question. 35 AUs.
Oh, wow, that's
That's
very far away. I didn't realize it.
Yeah. So this is 5.35 times 10 to the 9th, right? So it's equal to 5.35 times 10 to the 9th.
Am I right in assuming it's 11.5 light minutes between the Sun and Pluto?
Okay, cool. And then I need to know the...
No.
Wait, so that's big D. That's big D in meters.
That's not. Well, yeah, there you go. And
Yeah.
what?
And then what we need
And
is
what-
little d, which is the diameter, the actual diameter of Pluto, not the angular diameter, right? Okay. So trillion is 10 to the 12th? Oh, you are right. My bad. Yeah, you're right. So then this is 2.38 times 10 to the 6. Yeah, you're right.
So that's-
I
we're done
forgot
then, right?
trillion is to the 12th. Okay. Cool.
So we're done then, or
No, still gotta do a little bit more. Jeff is pretty invested in this non-Jeff question. I agree, dude. Okay, so the way to do this, the simple way is just to do d over d. So they would just do this. They would say 2.38 times 10 to the 6 over 5.35 times 10 to the 12th. Okay.
well, 10 to the 12th has its tens in common.
Yeah. So this will be just like times 10 to the minus 6. But whatever, we can pull our calculator out for it.
You don't need to. We just didn't write it. So
Oh,
3
it's
over 5. 0 to 38, 5 to 35 times
It's 2.38 divided by 5.35.
Yeah, that's what I said. 2 to 38 divided by 5.
Yeah. So 0.44 times 10 to the minus 6, which good is around 4.4 times 10 to the minus 7. Yeah, cool. Radians, which that's really tiny. That's super tiny. Okay.
And equation degree then.
Pardon?
Does the actual equation degree then?
Sorry, say that again.
Does the actual equation agree?
Oh, does the actual equation agree? I mean, maybe. Let's see. What was it again? Sorry.
2 arc sine of d over 2 equals diameter.
Yes. The hyper accurate format. So wait, do I just plug in this and the other thing?
But then would invalidate this equation as being untrue.
Wait, this doesn't have any sort of theta anywhere. Wait, where's theta again on this? What?
Yeah, go ahead. You place to something.
Wait, I've already rounded at some point. Yeah, what is that? One sec. Angular diameter equation. I want the full hyper exact form. No, these are all the approximations. This is what I liked. I liked this. I had it written. I'm just trying to remember exactly what it was.
We don't
That's
like
cool.
these.
Yeah. Well, this one. No, this is basically what we did. We did this basically.
Try putting as that form on that equation at the beginning in your search result. Try refining your search result. Yeah, no more than that. There, no.
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 You have to do more as that than that in your search result.
Maybe this has it. Here we go. This is it. Oh, they use tangent. This is actually kind of interesting. Because it is technically opposite over adjacent, right?
2 times arctangent of theta over 2d.
Mm-hmm. So let's show the exact way of how this works. This is like the triangle they build. Yeah, you were saying of a distant object, yeah. Because at that point you assume the hypotenuse is basically the same as the adjacent. That's
So
another
out-
approximation.
Equals 2 times s arctangent of s over 2d.
Mm-hmm. So in this case, it's 2 times tangent -1. Wait, did you get that one wrong? Or I thought other Jeff got that one wrong.
What's s though?
S is this, right? 10 to the 6 over 2 times 5.35 times 10 to the 12th, right? Let's see what happens there. Yeah, it is arctan, yeah. I mean, again, it's another approximation at that point. So, arctangent, 2.38, well, it's this, right? Oh, no, actually, no, because we have a factor of 2. I'm just gonna write it out. It's Monday. I don't want to be making silly algebra mistakes. I've already made too many silly algebra mistakes today. Divided by, and then this is 2 times 5.35 e to the 12th. What's up, user with lots of numbers next to them? Okay.
Answers do not agree.
They don't.
What's up?
That's a good question, did I?
You did not agree in some.
Because I was not in radian mode. That's why.
Maybe you didn't start working then.
Yeah, you gotta put things in radians. There we go. It's the same
Ding
thing.
ding. There we go.
Ding 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 ding. Yeah. This is the full.
Two more.
What's up, Zach? Good to see you, dude. Zach, I was saying we had a super fun time with your game on Friday. That was really fun. That was cool. I hope you do more of those. It's a good platform. Hello, I have a problem that my daughter needs help with.
He had one more prepared. He hadn't got to it yet.
Yeah, this is basically this. It's very, very close.
Where would you go?
User, if you need help, just submit a screenshot of the question. Yeah. To the link below.
中文我不知道.
Oh wait, is his user like in Chinese? Is that what you're saying? Are you seeing it?
Probably. It's almost certainly a Chinese using it.
Oh, that's cool. Yeah, send a screenshot there. Now Alpha Centauri, he says. Okay. Yeah. Until we get another question from someone else.
We already do technically, right?
Okay, let's look at Alpha Centauri. So I need to know some more information about Alpha Centauri, right? So Alpha Centauri distance. How far is Alpha? Wow. Should we do it in light years? Again, as long as they're equal. Oh, what's up, Alex? What's crack-a-lackin', dude? Yeah, what's up, dude? How's your birthday weekend?
I have a question.
What's up?
So you know how much points?
Well,
I have a question. Shut up.
No,
You muted yourself, dude.
What's up? You just muted yourself. Are you okay? What's up? No. Where's Alex? Alex is muted again. Okay.
Buenos dias.
Buenos
Hello?
dias. Yeah, what's up? There you are. Alex?
Stop. Something. Okay. I have a question. So like.
Yeah, what's up?
How much is it? How much points do I need to get a gift card?
10. Need 10 questions. 10 points. 10 points.
For how much?
For, I don't know, like 1,000 V-Bucks. It's like a $10
Can you
gift
get
card.
like a $10 PS5 gift card?
Yeah, you can totally get a $10 PS5 gift card. Yeah.
What's it called? Oh no, a $10 R6 card. It's like a game.
What's R6? Rainbow Six? Rainbow Six Siege?
Rainbow Six. Yes.
Y'all still play Rainbow Six Siege?
Yes.
Oh wow, that's a cool game. Yeah,
Like,
I mean, if it's for PlayStation and you can use PlayStation gift cards, then it'll work. So this is 851.
Wait, how long would it take for me to get the card?
How long? Whenever I get, well, once you have it, once you buy it in the Discord, I usually get it to you in a couple hours. You know, it's not instantaneous because I still have to go out and go buy it for you guys.
Oh yeah, I forgot. But I have a question.
You're not 4.37 like.
I don't have a question, but
What's
it's
up?
just I was just curious. But so what is cellular respiration? That's what I want to know.
Oh, cellular respiration? Yeah, that's a very big question. Because I mean, in a nutshell, cellular respiration is how the cells in living organisms convert. Sometimes it's oxygen, right? It converts oxygen into energy, which is called ATP. You're in like 8th grade, so I don't know. I don't know specifically how much of cellular respiration you're supposed to know, but in general, it's the way that oxygen gets converted into energy.
I know we heard about ATP, but what does that mean? What is ATP?
ATP stands for adenosine triphosphate, and it's kind of the building block of energy within cells. You can think about it as it's like a currency. It's like money. It's like dollars, but it's what your cells use to do things for energy.
And then the last thing, can you show me how to get a fraction? You know when you have a fraction, how do you get a percentage out of it?
Oh, okay.
By fraction.
Yeah, you could divide it. Yeah, but
with calculator or no calculator?
Yeah, are you allowed to use a calculator or no calculator?
No calculator.
No calculator. Okay. Well, I can show you that real quick. That's actually not too bad. Let's say, for instance, you had 3/25, and you wanted to write that as a decimal. Yeah. What you want to do is you want to try to turn your denominator into something that is 1 with a bunch of zeros next to it. So that can be 100, that can be 1,000, that can be 10,000, that can be 10, whatever's easiest. Okay? So what's something I could multiply 25 by in order to get like 1 and a bunch of zeros? Is he muted again? Alex. Okay.
I don't know what's wrong with my thing.
Oh, it's okay. Okay. What can I do? What can I multiply 25 by in order to get 1 and a bunch of zeros? We'll make this kind of easy. Let's say 100. What do I need to multiply 25 by to get you to 100?
So 100 to get 25
Yeah, how do I go from 25 to 100? How do I do that?
times 4.
Yes. Okay. So if you multiply this by 4, and then you multiply this by 4, you see how you get 12 over 100?
Yes.
Okay. 12 over 100 is going to be 0.12.
0.12.
Right. Do you remember, like, this is the tens place, right?
Yes. So
And
we
then
move the
this is-
decimal places.
Yeah, this is the 100. Well, okay. So I should say this is in the tens. This is the tenths. Technically is what it's called. So 12 100ths means you're going to go 2 places back and you're going to write 12. Okay?
12.
What if, for instance, I had, let's just say for shits and giggles, let's say I had like 6 100ths. How would you write that as a decimal?
6 100ths.
Mm-hmm.
Dang it.
Inside a pair.
What would we do?
Remember, this is the tenths. This is the hundredths. So how much is 6 hundredths?
0.006.
Just 0.06.
Oh, okay.
Okay.
Write it how you read it.
Now let's say if this was 6 over 1,000, that would be 0.006. Okay.
Oh, okay.
You see, because that's the tenths, the hundredths, and the thousandths place, and that's 6 1,000ths.
Yeah.
Okay. Cool.
Write it
So-
how you read it.
Yeah, write it how you read it, but some of these kids don't do either of those things anymore because I don't know, school's whack. But
I should point out that just we as adults would say point and so on, but he's a
Point.
kid, so 0
Point.
point something would be
Yeah,
much
it's okay.
more helpful.
yeah, oh, I see. If you say 0.0, yeah, I like saying 0 point first because yeah, it gets kind of weird. But they just say point first. Okay. So, yeah. Here's another good one, Alex. What if I had 3 over 10? How would I write that as a decimal?
0.3.
Good, nice, dude. Yeah, just 0.3, right? Because this is the tenths place, right? And you have 3 tenths, so that's 0.3.
Yeah.
Okay, nice. Okay, so here's another fun one we could do. Let's say we had 9 over 125, and you wanted to write that as a decimal.
9 over
Yeah, 9 over 125.
9 over 1. Something like point. Wouldn't it be? Actually, I don't know.
It's okay, dude. So remember, we want to try to turn this thing into something with 1 and a bunch of zeros. Okay.
And a bunch.
I'm gonna give you a hint because you may have not seen this because you're only in 8th grade, but I'm gonna try to turn 125 into 1,000. Do you know how to do that?
How do you do that?
You're gonna multiply it by 8.
Why? Why
One-
would you multiply?
Because if you check on the calculator, right, 125 times 8 is 1,000.
And also, 1/8 is 0.125.
Good. That is another good thing to know. Yeah, 1/8 is 0.125. Yeah, if you ever do like construction and stuff, you learn pretty quickly what an eighth is.
It's good to know your halves, thirds, fourths, fifths,
Exactly.
sixths, sevenths, eighths, ninths, tenths, 20ths, 25ths, 50ths,
So-
100.
So this gets you to 72
That'd
over
be best.
1,000. How would I write that as a decimal?
0.072.
Nice. Nice.
Am I right?
Yeah.
Which is
Yeah, that's it. That's the answer.
which
72
is what
one.
as percent.
Oh, as a percent. Oh,
Then we're
sorry.
taking
Were you asking to
percentages
write
and
these things as
percentages.
percents later? I don't think so, right?
Yeah.
That's
Yeah, I
the
was at-
job. You've been asked how do
Oh.
you write this percentages.
Oh, okay. So once you get to here, right? Once you get it into decimal form, you want to multiply it by 100, which means you move the decimal 2 places to the right.
So it would be 7.2%.
Nice. Yeah, that's it.
That's
So-
cool. Okay. Can you give me one more so I can know how to do it?
Yeah, for sure, dude.
3
Here, I got a good one.
is a good one for if you want a bit nice one. 3/15.
No, 15th sucks. What? 15th?
No, it's not. It doesn't. I tricked you. I pulled the trick when I say that. Read it. Think about it. 3/15.
What'd you said 3/15ths?
3/15.
Okay, this is not too bad. Okay.
It is. It's a tricky nice.
It is a tricky one. Yeah, okay. So, all right, how do we do this one? Alex.
You muted. There he is.
Can you? Hello?
Yeah.
Hello?
Yeah, can you hear me?
My thing is acting weird.
It's okay.
Wait, let me see if it's something wrong.
Wait and see if Alex can fix his technical difficulties. Do we have any other questions today?
Yes.
What would you say Kevin Sauce has one? Kevin has
Hello?
one? Yeah, there you are.
Hello?
I'm gonna put that
Can you hear us?
So wouldn't it be like 5%?
5%? It would be. How did you get to that?
Because if you multiply 3 times 5, it was 5. I think that's how it is. Maybe.
Yeah, it's not 5%. Yeah, sorry. Yeah, I got the 5s here. All right, here's what we want to do.
5%. No.
It's not 5%. My bad. Sorry. I was getting ahead of myself. It's something else.
How
But,
do you
okay.
do that to a nice number? Alex, how are you gonna get that to a nice
All right.
number?
So 3/15. Remember, you want to like try to turn this into something over like 100, right?
Yeah.
So
Also,
I-
wouldn't it be 150?
yeah, it's a 150 doesn't really help me.
150
So
helpful.
yeah, Seth asked a tricky one. Can you simplify 3/15ths first off? What could you do to simplify that?
Okay, like 3/15 to 5.
Yeah. Right? Do you see how you could divide this by 3 and divide this by 3? And then that would give you what?
So 1/5. 1/5.
Okay, good. That gets you 1/5.
Yep.
All right, now I want to turn this into like 1 over 10 or 1 over 100.
This one in is I wanted to make sure to know this rule. Simplify first.
Yeah, simplify versus good.
Simplify
Okay.
the mess, then deal with it.
So then how do we turn this to 1 over
Alex
1 over
is
whatever?
on mute again. So
Okay.
I don't know what's wrong. It's just muting. Unmute.
I'm gonna
That's
TP you
okay.
on TP you on Cav so I can unmute you if I have to.
Yeah, okay. All right. So then how do I get this to like 1 over 10 or 1 over 100?
We say 1 over 100. We could do 5 times. Let me think.
Mhm.
We could do 5 times. What do we do? 5 times 8, like we did last time, or no?
No, 5 times 8 would get me 40, right? I don't want to do that, right? Times 8?
40.
That's 40.
40 no help.
I want like 10 or
yeah,
100.
I had a number.
Or 20. 20 is also nice if you know your 20ths.
Yeah.
No,
Well, look at
not
this.
5
good.
times 20, yes.
You can do times 20. That's cool. Let's do that. All right, fine. So then that's 20 over 100.
Yeah.
Okay.
Wait, is it? Oh, it is.
Oh, is our Discord link not working? Sensation? Damn it.
Have I broken it?
Oh, there it
there
is.
we go.
There it is.
Which
It just
link?
it lags sometime. Okay, then how do I write 20 over 100 as like a decimal?
Wait, let me think. We just did it. Oh my god. Can you
Okay.
help me again?
Read it. Write it how you read it.
21 hundredths, right? So how many decimal
Oh,
places
what
is
did
a hundredth?
100, 2.
2 decimal places, right? So
Two
now
decimal places.
you got 2 decimal places to the hundredths place, and then what are you gonna write here?
2 0.
2 0.
Oh, and then percentages is what
And
your
then
goal
percent.
is.
What do we do for the last thing for percent?
I mean, we move the thing two places.
Mm-hmm. What does that get you?
20%.
Nice.
Is that right?
That is right.
That's dope.
Wait, I joined the what's it called? I joined the live as fast as I can because
Yeah.
I'm going to Puerto Rico for spring break.
You're going to Puerto Rico for spring break. That's cool, man, dude. Nice.
Yeah.
Puerto Rico's dope.
But what's it called? I have another question.
You got another question? What's up?
How do I redeem my points?
Go to the shop and just do. I think it's just /shop. There's a thing called like the prize room. There's a command there.
Wait, what's it called?
Lucky, I am
What's the
helping
place
family out. Okay, so if you go into our Discord, there is
Prize room?
there's a channel called Prize Room.
Yeah.
Wherever it is. There you go. And then here, you can come in and you just say /shop, and then it'll show you the shop, and then you can go through and you can buy prizes based on like how many coins you have. And then once you buy it, just send me a DM that you did.
Wait.
And
I do /shop.
yeah, just
What
/shop.
click on? What I click on? Like the
You click on the tier 1 thing you want to get, right? So here you would go back. You see where it says tier 1?
yeah.
And then you just click buy.
What? My thing is weird. So slash.
/shop.
Let me see.
These are called / commands in Discord. So you do /shop.
Yeah.
and
Wait,
it should
so I
just
do
be that one.
/. Wait. Let me see you do it really fast. Let me see you do it really fast.
Okay. Well, I just did. You do /shop. And it should pull up the shop
Okay.
like that.
I get it. So let me see. Dang. My phone's being weird.
Well, yeah, a lot of these things are hard to do on a phone. You really want to do these on a computer.
I don't have
Yeah.
a computer. I only have my school computer.
That's okay. I mean,
It's
we
still
try
a
to make-
computer, dude.
It's still a computer. It's a personal size computer.
So what I click on to get the thing?
So then you just click on tier 1, you hit buy.
Tier 1 hit buy.
Uh-huh.
So what do I do now? I'm sorry for bothering you.
It's okay, dude. I mean, did it say you got it?
Yeah, it said I got it. Purchase
Okay.
message.
Yeah. And then what does it say?
Dr. Gold, Dr. Gold. No, send a DM to Dr. Good with $10 gaming gift card you will
Yeah.
like, and he will send you a code.
Good. Yeah.
How
so,
do I DM? Oh,
how do you DM
I
me?
DM you personally.
Yeah, you just DM me personally. Which
Yeah,
one?
I'm
and,
sorry.
and then I'll buy you the gift card. That's how this works. You got it. It's your first time.
Thank you.
All right, congrats. Dude.
That's dope.
If you want to, you can show them 1/6 as well. So that's gonna be fun.
No, 1/6 is terrible. Let me see. We have someone else on the Twitch saying, "I'll just wait it here. -4x minus 4 equals +16 on diagram." What does that mean on diagram? I'm guessing
Oh,
there's some
I know,
there's an English barrier here happening.
I know.
But oh, okay.
-4 times -4 is 16.
Oh, okay.
Maybe they meant graph.
Show it on a diagram.
Oh, you just well. Okay. -4 times -4. You want to be shown that this is +16?
16. Yep.
Okay. I mean, if you really want to like get into it, I can write -4 as -1 times 4, and then that's going to be times -1 times 4, right? Do we agree with that so far, Dex? That like both of these things are equal to -4. And then the cool thing about multiplying numbers is that you can change the orders of things as much as you want. So here's what I'm gonna do. I'm gonna switch the orders here.
Wait. Jeff, don't.
What's wrong, dog?
16, not 6.
Oh, my bad. Yeah, whatever. Okay. You can't solve it? Hummy, what? Which one was that? 1 over x plus 1 plus sum of stuff equals x minus a for a greater than 0. Is that epsilon delta?
We'll get to that. I know. That's on deck. It's on deck. We'll get to it.
It's on deck. It's on deck. We'll get to it. Okay. All right. So here you go. So dex, right? Do you see how I grouped these two things together here, and then I put these two things together here? -1 times -1. Wait. Interesting. So -4, -3, -2, -1, 0, 1, 2. Oh, you mean like on a number line?
Yes.
You don't want to do this on a number line. You don't want to do this on a number line. Number lines are cool for adding and subtracting things, not multiplying.
It is. It's still for multiplication. It's easy. You just add -4 times.
You add -4 times.
Yeah.
How do you add something -4 times? Anyways, okay, -1 times -1 is just +1.
How do you know? Given that
You will
don't know
miss
that's
4, and then 4 times 4 is just 16.
Because you're given that you don't know -1 is 1.
Well, you know, it's at some points we have to come up with some universal truths. I'm pretty sure -1 times -1 is 1.
-1
Right?
times -1 is 1 due to the next step. If we did go back and you'll see the step. -1 times -1 times 16 is 16. Divide both by 16. -1 times -1 is 1.
The -1 times -1 is the hard part? Okay. Well, I don't know. Sue me. -1 times -1 is +1. If you don't believe that, then
hard to prove.
I've got a bridge to, what is it? A bridge to Arkansas? Is that I want to sell you? How's that thing go? Yeah.
Okay. Next on deck is Kevin with the
Kevin.
summation problem.
Where's the summation problem?
I have it on him. I have it on.
Do you
Go
have
back to March 12th, 2025, 8:57 p.m. With one of my reposts that has the problem. Suppose a is greater than 0. Find the solution to the following equation in the interval 0 to infinity.
Dex says it's an exam question for what class, dude? What class is asking you to prove that -1 times -1 is 1? Yeah. Oh, sorry. What's going on in the chat right here? One sec.
I should be heading out. You enjoy.
Oh, okay.
Yep, this is where I leave it, because this is...
All right, let's see. Suppose a is greater than 0. Find the solutions of the following equation with this interval. 1 over x plus 1 plus the sum of n factorial over all of this equals x minus a. Okay. They were singing Telescope. Oh, is this a telescoping series? Is that how this works? Yeah. Oh, I see. Yeah, so let's write out a couple of terms real quick. Oh, this is the AI song that you posted?
Hey, hey.
God, what is this music?
Show the way. I see a sequence in my book where terms seem big but vanish when you look. One part's negative, the next the same. They'll cancel perfectly. Ain't that
Dude,
the game?
this AI math stuff is too much, dude. God damn it.
Before you know the sum's so neat, everything collapses with a beat. Oh baby, I'll show you.
Oh, okay, it's a collapsing series. Okay, that's a fun song. But yeah, okay, I get what you're getting to. This is like a partial fractions type stuff. So let's look at the first one. So this is 1 over x plus 1 plus, if n equals 1, that's 2 factorial. So that's just 2. Sorry, it's 1 factorial, sorry. All over x plus 1, x plus 2. And then that's going to be plus 2 factorial over x plus 1, x plus 2, x plus 3, and then so forth and so forth. I think, right? If, where's Wolfram? Come on, Wolfram. Slow save. So 1 over x plus 1, x plus 2. Let's try that out. So that's the first one's positive and the next one's negative, right? Okay. So this is the same thing as 1 over x plus 1 plus 1 over x plus 1 minus 1 over x plus 2. And then this one, and then there's a 2 on here, I guess. Okay, cool. So that's negative 2 on the middle one, and then positive on the outer 2. Is that what that is? Okay, so that's plus 1 over x plus 1 minus 2 over x plus 2. One sec. Plus 1 over x plus 3. Interesting. Okay. It is interesting, yeah. Because I wonder what the trend is for this. Because we keep adding more factors, right? And then 3 factorial is 6. And then we're going up to x plus 4. Oh, this almost looks like a Pascal triangle, right? Now I have 1, 1, 3, 1, right? So then this is plus 3 factorial over x plus 1, x plus 4. And that's equal to this. Okay. So I don't, usually in a telescoping series, things will start canceling. Usually this one would get canceled out by one of the other ones, or like this would cancel out with this, but it doesn't look like they are. Right? This is getting just more and more negative. And then this is getting more and more positive. And then we're just adding more x plus 1s. This is really ugly, actually. Oh, man. I wonder what... Is there a theory about this? So, yeah, this doesn't really telescope. Usually when things telescope, they, like, cancel out, which is nice. This one's not. Which, I'm trying to remember what's, like, you know, what's, like, a good example of, like, a telescoping series. Yeah. This is a good example of one. Yeah, like the sum of 1 over n times n plus 1 goes to 1 over n minus 1 over n plus 1. And as you start writing out the first couple terms of these... What happens is, this one ends up canceling with the one from before. So here you have 1 minus 1/2 plus 1/2 minus 1/3. This cancels out with this. And then this would cancel out with 1 over here. And so all you're really left with is 1. And then the n plus 1 term, right? And then, yeah. Where n is like the biggest number you're going to. Which as n goes to infinity... This is the same thing as 1 minus 1 over n plus 1. Okay, because this one always cancels out with this one. Yeah, okay, got you. Right, and then this just goes... Yeah, okay. Ooh, okay. This is kind of cool, actually. So... Look at the... Look for a telescoping form. Okay. Okay, so a sub n is some series, which is equal to n factorial over x plus 1 dot 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 x plus n. It's x plus n plus 1, really. Okay, I think I'm starting to see it. This is interesting. Okay. Okay. N factorial over this x plus 1 x plus 2 dot 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 x plus n plus 1 has to be equal to some telescoping series of an minus the an plus 1 term. Okay. So, we're gonna assume a sub n is equal to just n factorial over x plus 1 x plus n then a n plus 1 is equal to n plus 1 n factorial over x plus 1 or no x plus n plus 1. Okay. this is x plus 1 dot 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 x plus 1 plus n. Okay, and then we can factor out this part of it. So that gets me n factorial over x plus 1 dot 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 x plus n. It's my dad, DJ. Yo, what's up now, Sage? Yeah, we're teaching. We're doing some math right now, dude. Doing some math. Okay, so then this is 1 minus, and then this is n plus 1 over x plus 1 plus n. Okay. My daughter's watching her future teacher. Hey! Good to see you, Lake, dude. I'm amazed. Yeah. Okay. Let's see. Equals n factorial times x over x plus n plus 1? Really? How does that work out? He's a golden teacher. It's a good strain of vegetables, if you know what I'm talking about. This last step is kind of bugging me. Maybe you guys can like help me out with this one. Trying to see some inspo. I get this. This is okay. I'm cool with this. But then they get to this step where they're saying this is times x. Oh, I see. They're combining the fractions here. Okay, that's actually pretty cool. So they're saying this right here is the same thing as x plus 1 plus n over x plus 1 plus n. And then it's minus n minus 1 all over the same thing. Okay, so this goes away. Okay, and then this goes away. Awesome. Okay, so then you're left with just x over x plus n plus 1. Which is... someone got the halo going. Master Chief. One sec. Where's that last X though? Oh, very cool. But now this X and this X cancel out. Okay. So now you're left with this, which is what we wanted, right? N factorial over X plus 1 blank 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 X plus n plus 1. Okay, cool. So, yeah. So what we now just showed, right, is that the sum as n equals 1 to infinity of a sub n minus a sub n plus 1 is equal to what this original thing was. Okay. And that's going to be the same thing as a1 minus the limit as n goes to infinity of a big N plus 1. That comes from this. Remember when we did this? And how it was just equal to the first term minus the last term? Because what we're showing here, right, is that as we add this, the n plus, so watch it. This would be a1 minus a2 plus a2 minus a3 plus a3 minus a4. These ones are always going to cancel. These are always going to go away. And so you're going to be left with just the first term minus the infinity term that you go to. Do you see that, Hummer? That's pretty cool. Yeah, right? I'm sorry. Yeah. Okay. So the first term, that's just 1 factorial over x times x plus 1. The limit as n goes to infinity, so that's n plus 1 factorial over x plus 1, x plus 2, blank, 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 x plus n plus 1. Yeah, this is a very cool trick. Yeah, well, once you can show that it's some nth term minus the n plus 1 term, then you can show that they cancel each other and they just telescope. Yeah. Yeah, no, it's a really cool trick. Okay. So. Right. Okay. Then what we say, oh, and then there's still an x down here, is that as long as x is greater than 0, okay, this is going to grow faster than this, because this is just going to be the same thing as like n plus 1 times n minus 1 factorial. Yeah. Whereas this is x plus n plus 1, and this goes all the way down. So this is going to be bigger than this, so this is going to go to 0. All right. So now you're just left with this whole sum here. Ends up just being 1 over x times x plus 1. Okay. So now you have 1 over x plus 1 plus 1 over x plus 1 has to be equal to x minus a. Okay, not so bad. So this is x over x squared plus x is equal to x minus 9. Which is, yeah, kind of ugly. I can pull an x out from all the sides, right? So this is 1 over x plus 1 is equal to 1 minus 9 over x. Well, I don't really want to do that. Yeah, nope. 1 sec. 1 over x plus 1 plus 1 over x plus 1. And this is all equal to, oh, x minus a, not x minus 9. What am I saying? Sorry. Okay. I feel like I can divide by x at least, right? So 0 is equal to x plus 1. And then it's 1 minus a over x. Which then we can divide by x plus 1. Okay. Just assume, because x has to be greater than 0, right? Isn't that what we said earlier here? Yeah, x has to be greater than 0. So x couldn't be 0. That's why we were cool to divide by x. And then we were also cool to divide by this, because this only works if x equals negative 1, which we don't have. Okay. So then I get a over x is equal to 1. So does a just equal x? Or no, x just equals 1 over a then. Or x equals a. That's what I'm saying. Yeah. Yeah, okay. Yes, cool. All right, awesome. Nice. That was a tricky one. Okay, cool. That was an interesting one, Kev. Thanks for putting me through a little bit of a ringer on that one. Oh, left-hand side is just 1 over x. Wait. Left-hand side is just 1 over x. Is this a over x equals 1? Did I do that wrong? I thought I divided everything by x. Because, let me see. 1 is equal. 1 equals x squared minus ax. You're right, they do get something similar though, Endar. Let me see real quick. Let me see where they made a mistake. So I agree with this. So then they say this is the same thing as 1 over x. 1 plus 1 over x. Oh. Yeah. Oh, I see. Yes, sorry. Yeah, this shouldn't be 0. This should be 1. Okay. Got you. Okay. That's where I messed up. Yeah. Right. I divided by x. And then I divided by this. Uh-huh. Well, actually, wait. This is this, and then this is a quadratic, though, right? I think if I really wanted to, what I should have done is I should have subtracted from x on this side, and then divided by 0. Divide by x, that would have given me 0. Uh-huh. I see. Okay, and then this is a quadratic, because this is x minus a over x minus a plus 1 is equal to 1. Right? Which, okay, you can then just multiply everything through by x. Oh, thanks, P127. Yeah, okay. So then x equals x squared minus ax plus x. This goes away. Okay. So I could just get x squared minus ax minus a is equal to 0? Minus a equals 0? Yes. Oh, I see. Yeah, he was talking about like if I divide this by x, it doesn't. Yes. Okay. Sorry, my bad. This is the difference. Yep. Yeah. Okay. Thank you. Sorry, I thought I was going crazy here for a second. Okay. That's a simple algebra mistake. God damn, I should be making that mistake. Okay, I see what you're saying. Yes, thank you. Okay, so now it's x minus ax plus 1 minus a. Okay, now the ones cancel. Okay, right? So I get 0 is equal to... x minus ax minus a? Is that okay? Oh, sorry, I hit the wrong thing again. Oh, wait a minute. When these added, this should have been x plus 1. Okay. No, I made so many algebra mistakes here. Sorry. This is just all backwards. Okay. Yeah. Okay. This is correct now. And now I think I want to pull out an x from the top and the just from the bottom. So that's x plus 1. For x, 1 plus x equal to x minus a. And then we multiply through by this. So this is x squared minus ax. And then this is x plus 1 over 1 plus x. This is the same thing as 1. Okay, got it. Okay. My bad. Okay. X squared minus 8x minus ax minus 1 equals to 0. Now this is a quadratic formula. Plus, right? All over 2. Okay. And then we can only take the positive solution. So it's this. It's a plus the square root of a squared plus 4 all over 2. There you go. That's the correct one, Kevin. I forgot to add the plus 1 here. And then, yeah, these cancel. Okay. Cool. Thanks for all the help on those, guys. Whew. Okay. That's a mess of a question, dude. Won't hurt my soul a little bit. Okay, let's see. Do we have any more questions for today? I think no, we're good. And what is this? Oh, we've been streaming for 2 hours and 20 minutes. Sensation. We've been on here for a second.
Indeed.
I've just been lost in the math land. Okay, cool. All right. I think that's good for today. Yeah, let's close the stream out. All right. Thank you, everyone, for coming to Actual Education Office Hours today. Had a fun time going through all you guys' math and science questions. Again, if you ever have questions, come by our stream, and you can submit your screenshots for us to go over. Here's the calendar for when we have our streaming schedule. So if you ever want to check out when we're streaming, or all your other favorite math and science streamers are streaming, this is the website. So looks like no one else is today. Well, I guess Zach must be taking a break now. But it looks like, yeah, we're going to be the only big ones here for the next couple weeks. Okay, what's up, Cosmic? Good to see you, dude. Alright, let me see who we're going to go raid. Have a good night. Yeah, no, you're good, dude. Good to see you as well. Appreciate it. Let's go raid someone. Who do we want to go raid? Who am I following? Reading Harry Potter and the Mystery of the Mystery of the Prince. Is that like the Half-Blood Prince in Spanish? Let's see. Potential's doing a proposal due for NASA Tech Leap, and then yeah, let's go say hi to. I like High Potential. He's a funny guy. Yeah. Let's go say hi to him. Oh, we can't raid him? Uh-oh. Why can't we raid him? What's with this thing? I can't raid certain people anymore. I wonder if, like, Twitch is starting to restrict certain people's accounts. This guy's looking at, like, astronomy stuff. Can I raid this person? Oh, there we go. Nice. That's gonna work. Okay. Cool. All right. Thanks again for coming by. Our next stream will be tomorrow. That's gonna be an hour later at 2 p.m. Sorry, at 4 p.m. Pacific, 5 p.m. Mountain, 6 p.m. Central, 7 p.m. Eastern. Until then, have a wonderful start of your week, wonderful rest of your Monday, and we will see you tomorrow. Okay. Peace out.